Welcome to a podcast dealing with regression, so-called regression lines, and we'll close with the idea of correlation. So let's start off with a sort of a classic example. Let's say an IB theory of knowledge course, which for new candidates now has the two components, namely a TOK exhibition and a TOK essay. So let's say looking back in time, we had the final marks for 12 candidates. You can see the X values would be out of a possible score of 10, the exhibition marks, and the essay mark would be the Y values. So here's a candidate who received a 2 in his or her exhibition and a 4 in the essay, and you get the idea. So let's just jump straight into technology because that's what you will always be doing with IB regarding regression. Let's determine the so-called scatter plot, scatter diagram. We have to use just some basic language to describe the nature of the relationship between the two variables. We will then find classically a regression line, so-called y on x, which is basically saying y is a function of x. And then we'll use that regression line to do some prediction, and we'll make some remarks about interpolation and extrapolation. So basically, if IB were to give you some kind of a scatter plot, scatter diagram, which they classically do, and you were asked to describe the actual relationship. This looks like it's moderate to possibly even moderate to slightly strong positive in terms of if a line were to be fitted by eye to the data here, it's a line that would rise from left to right, hence a positive slope. So it's a positive relationship as opposed to one where it trends down. And it looks like it's moderately strong looking linear. And so that kind of language would be what they would be looking for in terms of describing the actual relationship. So to find the so-called regression equation y on x, or namely y as a function of x, you want to go to your stat menu, and through the editor, of course, you want to get, let's put the x values in L1 and the y values in L2. That's pretty straightforward. And in fact, that is set with a proper window, the graph that you actually see here in terms of the spread. And so if you then go stats and arrow over to calculations, if you drop down to feature 4 here, it is a linear regression model. And you might want to note that there is another linear regression model here where it just switches the nature of A and B. But in this context, of course, A would be the coefficient on the X value, so that would be the slope value that's coming, and B would be the Y-intercept. And so when you click on that and ask it for, or feed into it L1, L2, you should get, coming back to the screen, something that looks like this. And if you have a bit more information there, great. If not, I'll talk about that towards the end. And so you do not have editor control over these. You've got to maybe write these down to 4 sig figs. And then if you put them into your y equals menu to actually graph the line, you can see here is a line that's the so-called line of best fit that's going through the data values. And so if you wanted to use this regression line to actually predict the candidate's essay mark, given you knew her exhibition mark is a 9, you could actually just use second calc, go to value, plug in 9, and it'll give you what looks like almost 9 here in terms of the y value. And so hence, an exhibition mark of 9 would be used to predict an essay mark of 9 when you round that value up. All right. We are working, if you work between 0 marks and 10, anything you try to work in between in terms of predicting a value for x and which y value would you get, you are essentially interpolating, right? The process of interpolation is working sort of legally within those domain bounds. If you try to go outside of those bounds and use the model, at 11, 12, if that had relevance, it does not in this case, but you'd be trying to extrapolate because you'd be outside of the domain in which this sort of model, this regression model was built. So keep an eye on interpolation versus extrapolation. So there is a trick question where, given we have the so-called y on x, or y as a function of x, what if you tried to use this to work backwards? Well, you can't, right? So if you try to say, like, what's the essay value of 8 giving you in terms of the candidate's exhibition mark, try to say, okay, you plug in the y value, which represents an SA mark now, and try to work backwards to come up with some kind of an x value. It seems like it actually works, but you can't use a y on x line in this fashion. You actually need a regression line of x on y. And so you got to switch this around. So that would require you, since you've got L1 and L2 already safely into your GDC, if you just switch the lists in terms of asking for that linear regression, you'll get a new model. And so this new model, you have to be a little bit careful, even though it looks like y is a function of x here, because you've switched the lists here. You're actually getting x as a function of y. So this new model looks like this. And now you can safely say, okay, if the SA mark is 8, and now we're saying that the exhibition mark is a function of the SA mark, because that's what you've done here in terms of what's happening notationally, then you would end up getting that that exhibition mark would be predicted to be 7, given the SA mark is 8. All right, so be mindful of IB perhaps asking you to work backwards in a sense where you're not allowed. You can only talk about a new function that in this case would make the so-called exhibition mark a function of the SA mark by turning the analysis around. And so a couple of other salient points. When you put in, if I go back to the original model that we talked about, L1 and L2, and we got this function here, if there's no other information provided, that means your diagnostics have been turned off. And so if you go to your mode menu, and then down here where there's stat diagnostics, it's typically off. And by the way, when you do that RAM clear just before the papers in May, for some reason the GDC defaults to turning off the stat diagnostics, so you need to turn them back on. And when you turn them back on and run the regression analysis with L1 and L2 again, you end up getting a little bit more information, namely the so-called Pearson's product moment correlation coefficient, this R value, which some of you, of course, have used in your IA in terms of its closeness to 1 indicates the strength of the actual relationship. It also can be negative, of course, if the line is falling from left to right. So it will safely be some value between -1 and 1, and the closer you are to 1 and -1 respectively, the stronger the actual relationship is in either a positive or a negative sense. The other thing worth noting, if you were to be asked by IB to actually graph the regression line, a requirement is that the line must pass through the actual mean of each of the values in question. So what I've done is just remind you, because you've got L1 and L2 safely holding your values, if you just simply run one variable stats on L1, which are the x values, it will give you the mean of those 12 values. And if you run one variable stats again on L2, it'll give you the mean of those 12 values. And so then if you were actually asked to graph the line, you would have to point out, this is roughly trying to be 6.5, of course, that the actual line of best fit, that regression line, needs to go through 6, 6.5. Otherwise, you'd probably lose a mark for that. That's pretty much it. Pretty straightforward. Not a lot of tricks involved with regression, so you're going to welcome such a question from IB, and some of the particulars of not falling into the trap of the trick question, not extrapolating beyond the domain, and certainly going through the x bar, y bar value if asked to graph are just some of the salient points to make sure you can get as many marks as possible. Okay, that's it. Thank you. Bye.